Imagine tuning into a radio late at night and hearing something that doesn't belong. No music, no static, just a pattern that feels intentional, distant, and ancient. And now imagine that signal didn't come from Earth at all, but from somewhere deep in the cosmos, traveling for millions or even billions of years before brushing past our planet for a fleeting moment. Because right now scientists are detecting strange, persistent signals from space that defy easy explanation. And these are not science fiction fantasies or internet hoaxes, but real recorded data collected by some of the most advanced instruments humanity has ever built. And today, we're diving into echoes from the void, unexplained cosmic signals baffling scientists in 2026, signals that challenge what we know about physics, astronomy, and even our place in the universe. But before we go further, ask yourself this: what if space has never been silent at all? What if it has always been speaking in a language we're only just beginning to hear? And what if these signals are not accidents but messages, warnings, or natural phenomena so extreme they stretch the limits of human understanding? Welcome to the channel, where we explore real mysteries, real science, and real unanswered questions at the edge of human knowledge. And if you're fascinated by the unknown, the unexplained, and the frontier of discovery, make sure to subscribe now so you don't miss what comes next. Because as our technology improves, the universe is revealing secrets faster than we can explain them. And tonight's story begins with a simple truth: the universe is broadcasting, and we don't yet know who or what is on the other end. Fast radio bursts, known as FRBs, are among the most mysterious phenomena ever detected, appearing as incredibly powerful pulses of radio energy that lasts only milliseconds, yet release more energy in that instant than our sun emits in days or even weeks. And the terrifying part is that they come from far beyond our galaxy, crossing unimaginable distances before suddenly lighting up our detectors and vanishing without warning, leaving scientists scrambling to understand what could produce such immense power so quickly. And while early discoveries suggested they might be rare, we now know they are happening constantly across the universe, with some repeating in strange, almost rhythmic patterns that raise uncomfortable questions about their origin. Because while some FRBs appear random, others repeat from the same location, sometimes following cycles that resemble intentional timing rather than chaotic natural events. And although leading theories point to exotic objects like magnetars, ultra-dense neutron stars with magnetic fields trillions of times stronger than Earth's, no single explanation fits all observed data, especially when some bursts display polarization, frequency drift, and energy signatures that push known physics to its breaking point, forcing researchers to admit that while we may be seeing the fingerprints of extreme astrophysical processes, we may also be witnessing something entirely new, something that suggests the universe is far more active, violent, and structured than we once believed. In late 2020, astronomers working with the Breakthrough Listen initiative detected a signal that instantly sent shockwaves through the scientific community, known as BLC-1. This narrowband radio transmission appeared to originate from the direction of Proxima Centauri, the closest star system to our own, and one known to host at least one potentially habitable exoplanet. And what made BLC-1 so unsettling was how clean and focused it appeared. Unlike most cosmic noise, it occupied a very specific frequency range, rarely produced by natural astrophysical sources. And for months, researchers carefully analyzed the data, eliminating satellites, aircraft, and known terrestrial interference, while public speculation exploded with excitement and fear. Because for a brief moment, BLC-1 seemed to fit the profile of what scientists had long predicted a technological signal might look like. Yet, after extensive review, the official explanation concluded that the signal was most likely human-made interference reflected in a complex and misleading way. But even today, that explanation leaves lingering doubts, because no exact source was definitively identified. And the incident exposed a deeper truth, that as our detection methods grow more sensitive, the line between cosmic signals and human noise becomes harder to draw. And one day, when a signal truly cannot be dismissed, we may not be emotionally or scientifically prepared for what it means. Radio waves are not the only way the universe communicates its most violent secrets. Because in recent years scientists have begun listening to space-time itself through gravitational waves, faint ripples caused by colossal events like black hole mergers and neutron-star collisions, confirming predictions made over a century ago and opening an entirely new window into the cosmos. While at the same time, ghostly particles known as neutrinos are being detected passing effortlessly through Earth, carrying information from the most extreme environments imaginable, such as exploding stars and active galactic nuclei, places where matter behaves in ways we cannot replicate. And then there are pulsars and magnetars, spinning stellar remnants that act like cosmic lighthouses, emitting precise beams of radiation that sometimes glitch, stutter, or suddenly change behavior in ways that defy current models, reminding us that even the so-called understood objects of space still hold surprises. And taken together, these signals form a haunting picture of a universe that is constantly alive with activity, whispers, shocks, and pulses, most of which humanity has only just begun to notice, let alone comprehend. As we move deeper into the 21st century, the search for answers is accelerating, with next-generation observatories like the Square Kilometre Array promising to detect signals with unprecedented clarity and scale, while artificial intelligence is transforming astronomy by filtering massive datasets, spotting anomalies, and revealing patterns no human could find alone. And this partnership between human curiosity and machine intelligence may be the key to finally understanding whether these echoes from the void are purely natural or something far more profound. Because if even one signal is ever confirmed to be artificial, the implications would reshape philosophy, religion, science, and civilization itself, forcing humanity to confront the possibility that we are not alone and never have been. But even if all these signals turn out to have natural explanations, they still reveal a universe far stranger and more beautiful than we imagined, one that challenges us to keep listening, keep questioning, and keep exploring. Because the greatest discoveries often begin not with answers, but with a single unexplained signal drifting quietly through the dark, waiting for someone curious enough to notice.